Hello everyone, welcome back to our data structures and algorithm series. So the question which we'll be solving today is check if the array is sorted and rotated. So in the input we have been given an array and we have to check if it is a rotated sorted array. What do you mean by rotated sorted array? That the array was initially sorted but then it was rotated at some point by some units and then it becomes whatever the array given to us. For example, in this case this was the original array, and now shift this array by 3 positions to the right. So this array becomes like this, right? 3 4 5 will come at the start and 1 2 will go at the end. This is how we shift the array to the right by 3 positions, right? So we have to check like if the array was initially sorted or not after shifting a few positions, right? Now take this array. It is already sorted, which means the original array was also like this, and we have shifted it by 0 position, which is x equal to 0. Right? Now take this array. Now there is no way we can sort this array by shifting elements, right? Because like you do anything, you shift it by any elements, it won't be sorted again, right? So this was never sorted. So in this case we have returned a false, and in these cases we have returned true because it was originally sorted. So we have to just return true or false. That if it was sorted before, then we have to return true. If it wasn't sorted at any point, then we have to return false. Right? So that's what we have to check, right? So how will you solve this question? So let's understand. Let's take this example: 3 4 5 1 2. 3 4 5 1 and 2. So our original array was 1 2 3 4 5 in this case, right? And it was shifted by 3 points, like 3 units. So after shifting it became 3 4 5 1 and 2, right? So one thing to observe in a rotated sorted array is it is sorted in two parts. Like if you rotate it by any number of units, it will still be sorted but in two parts. Like this is the pivot in this case, so this is also sorted like 1 and 2. This is sorted and this is also sorted 3 4 5, and this element is smaller than this element, right? So we have to uh, this is how we will like check if this array was initially sorted or not. So if the array is actually divided in two parts and those two parts are sorted in itself, right, then we can say yeah, the array was rotated at some point. So let's draw this example again: 3 4 5 1 2. So what I will have to do in first I'll have to check where the array was, where the partition lies, like where the partition lies. So in this case here it's the partition. So first I will find the index of partition. How will I find? I will like this element is greater than the previous one, this is greater than the previous one. So as soon as I get an element which is smaller than the previous one, like in this case 1 is smaller than 5. So as soon as I get an element which is smaller than the previous one, I can say yeah, the array was rotated at that point. Once I get this, now I know this part of array is in increasing order. Now what I have to check, once I get the pivot point, I have to just check whatever array is remaining after that pivot point. In this case it is 1 and 2. So whatever array is remaining after that pivot point, it is also sorted, right? If that array is sorted and this last element is smaller than the first element, like this 3, this 2 is smaller than the first element, and this array is sorted, like this remaining array is also sorted and this element is smaller than the first one, then I can say the array is rotated sorted array, right? So that's how we'll solve this question. So that's what I did first. First, my initial, the break index is -1, right? So what I did first, I found the first element nums of I plus 1 is less than nums of I, like in this case 1. Like let's write it again: 3 4 5 1 and 2. So nums of I plus 1, which is this, is less than nums of I, which is this. So this is the point where I will break. So I have stored that index and then I break, right? I stored like this index in this case I plus 1, and then I broke. Now I ran a loop. Now before running the loop I check if my index never like index is still -1. Which, what does this mean? When, in which case my index will remain -1. For example, it is already like this and initially index is -1. Now I will never get an element which is smaller than the previous one because this is in increasing order, which means my index will remain -1. So if my index remains -1, which means that array is already sorted. So in that case I will directly return true. There is no need to check, right? For example, in this case, right? Now if my index is not -1, which means there is a pivot present, right? I can say there is a pivot present in my array. Now once I found that pivot, for example in this case here is the pivot, I will just check I'll start from the pivot and I'll go till last index. That's what I did in this case. I started from the pivot, which is 1, and I went till the last, which is 1 2. I checked if this nums of I is always greater. then it will be sorted. So at any point, if I get an element which is smaller than the previous one, for example, this is 1 2, so it is fine. But if it was, let's say, 1 and let's say 0, so now this element is smaller. So even if I get any element, if I get any element which is smaller than the previous one, I can directly return false, which means this is not sorted, which means this is not sorted rotated, sorry. Or I can say if nums of I is greater than nums of 0, which means whatever my this index like this array was a 3 4 5 1 2, all these elements will be should be smaller than this because it is rotated at this point. So I can say all these elements are smaller than the first index. So everywhere I will check if my nums of I is it smaller than nums of 0, then it is okay. But if it is greater, if any of these elements is greater than the first index, then it is not rotated sorted. That's what I check here. If any of my elements is greater than nums of 0, return false. Or if any of the element is smaller than the previous, like this was 1 2, this is greater, so it will not return false. But if any of the element is smaller than the previous, return false. So in these two cases I will return false. Else if these conditions never became true, for example in this array 3 4 5 1 2, these conditions will never become true. Why? Because 1 and 2 both are smaller than 3, and 1 uh, 2 is greater than 1. So these conditions will never run. These conditions will never run. I will never return false. In this case I will return true, right? So that's how I'll solve the question. So the basic approach is just find the pivot, right? First find the pivot, and then, which is this idx I have used. First find the pivot and then check from pivot to the last index, are they sorted in increasing order, and are those elements greater than the are those elements smaller than the first index. If they are not, then return false, right? And if these two conditions never done, I return true. So that's the basic approach to solve this question, right? So the time complexity is big O of n because first you ran a loop from 0 to index and then from index to n. So the total time complexity is big O of n, right? And the space complexity is constant. We haven't used any extra array. So if I run this, this should run. And even if I submit this will work. So yeah. So that's how we solve this question. And that's it in today's video. If you like the video, please do subscribe to our channel, and I'll meet you in the next one. Thank you.